Hi, I'm Tobias. I work for VSHN and I live in Zurich in Switzerland. VSHN operates managed services for the customers all around the world, even in Australia for the Australian government. Usually the customers have high security requirements and some of them are in highly regulated areas like banks, insurances or telecom companies. About a year ago, we decided to base our next generation managed services offering on Kubernetes and discover Crossplane as the potential control plane to achieve that. With our open source tooling called Project Syn, we created the basis to orchestrate configuration on a huge fleet of Kubernetes clusters, including the deployment and configuration of Crossplane itself. Our first implementation with Crossplane as the control plane together with Project Syn is made for the biggest Swiss telecommunication company called Swisscom. At the beginning, Swisscom will offer Redis and MariaDB Galera in their internal services marketplace as a managed service, running on Kubernetes at massive scale. The amount of expected service instances is so high that it's not possible to run them all on a single cluster of their internal Kubernetes offering. These services are mostly consumed by applications running on Cloud Foundry, and the services need to be available as a full self-service offering in their marketplace. All these services are running in Swisscom's own data center and infrastructure with high security measures. Provisioning and managing of the services is all orchestrated by Crossplane with a bunch of providers, namely the Helm and the SQL provider. Both providers are available under the Crossplane contrib GitHub organization. With the Helm provider, we are able to leverage already available and well-maintained help charts like the ones from Bitnami for doing the actual service provisioning. For a perfect integration into the Cloud Foundry world, we developed an open service broker API compatible application which is tightly coupled to the Crossplane core concepts. It maps the various open service broker concepts, for example service offering, service plan or service instance, directly onto Crossplane objects like composite resource definitions, compositions or composite resources. All state of the Open Service Broker API application is stored either in or with Crossplane objects. As mentioned before, the expected amount of service instances does not fit onto one Kubernetes cluster of the customer's internal Kubernetes offering, which is based on PKS. Therefore, there are many service clusters on which the actual services are running, and one control cluster on which Crossplane and the Open Service Broker API is running. Deploying services to the service clusters is achieved by leveraging the possibilities of the Helm provider, which is capable of installing Helm charts onto remote Kubernetes clusters. As the Helm provider still lacks some features, like handling connection secrets, the Open Service Broker API application still has to connect to the service clusters to get more details about the service. This for sure will get improved over time, so that no access to the service clusters except for Crossplane itself is needed anymore. Our Crossplane Open Service Broker API compatible application is open sourced on GitHub. It's already being used in testing to assure stability and compatibility. The code still has its rough edges and contains some customer-specific endpoints, but our goal is to continue driving the code into production quality and move it into the Crossplane contrib GitHub organization to enable community contributions. If you want to know more about what he did, please reach out to me at my email address or on Twitter. Thanks for listening and enjoy the rest of the Crossplane Community Day.